Well, I think it's always best to start with some quick introductions so the audience knows kind of who's around the virtual table, if you will. My name is Ben Hubbard. I'm the CEO of Nexus PMG, a low carbon infrastructure advisory and development firm based out of the United States. Specialize in various different types of technologies and markets, but predominantly anything that reduces carbon intensity, enhances resource efficiency. So I'll be moderating today with the lovely guests and Gabriel and Laureen. So Laureen, why don't you kick us off with a quick introduction, a little bit about yourself and your business, and then we'll move to Gabriel and then get started with a little bit of the roundtable discussion.
Excellent. Thank you, Ben. As Ben said, my name is Laureen Meroueh. I'm the CEO of Alchemr. Alchemr is democratizing green hydrogen at the scale and pace required to meet our net zero 2050 goals. And we're doing this by significantly lowering the cost of green hydrogen production.
Hi, everybody. My name is Gabriel. I am the Chief Executive Officer at Ecolectro. Our mission is to use chemistry to decarbonize the economy, particularly the hard decarbonized sectors. So we're making chemical solutions for green hydrogen production to dramatically lower the cost of electrolysis and hence making green hydrogen cost competitive with gray hydrogen or blue hydrogen or fossil fuel derived solutions today.
All right, well, we appreciate that. And I apologize to the audience in advance. I'm in the airport in Vancouver, so there's too much background noise. I'll do my best to stay on mute majority of the time and let these two fine folks do most of the talking. But and hopefully these earpods do their job and filter out most of the noise. So today we're going to be talking a lot about some of the decarbonization pathways that are occurring predominantly around hydrogen production. There's a pretty tremendous amount of momentum building around the hydrogen economy. The first thing I wanted to kind of posture to you, Laureen, was, with this momentum that seems to be building and the emergence of kind of this robust hydrogen economy and more announcements from, big renewable volume obligators and oil and gas businesses and a commitment to what seems to be a growing economy. Looking at kind of the devil's advocate view, what do you see to be the primary barriers to kind of unlock the broader use of hydrogen? And how are you and your business kind of attacking that?
Thanks, Ben. I think that the most obvious kind of reason is the cost. So the cost of green hydrogen production. And then, of course, along other parts of the value chain. So the cost of the renewable power coming in, as well as transportation. Now, there are definitely mitigation techniques for these various components. So transportation, you can produce on site or really transport the hydrogen across smaller distances by pipeline. And then on the renewable power part, we have amazing companies working on reducing the cost of renewable power, such as Atravita Science, which you heard from an hour ago. And so where we're focused is the green hydrogen production component, because there really aren't that many solutions to lowering that cost. And so what my company does is we're building a water electrolyzer that does not use any precious metals or expensive metals like the existing solutions do, dramatically reducing cost, eliminating supply chain concerns, but also we're going to the scale required to unlock low-cost green hydrogen. So we will be mass producing 500 kilowatt plus stacks. And this allows us to generate green hydrogen at less than $1.50 per kilogram by 2025.
So, Laureen, let me pull on that thread a little bit before we move to Gabriel. What, with obviously a big advantage being not having to use those precious metals, what percentage kind of the cost reduction or the overall, capital costs associated with the production of with that production is seen by those precious metals? I mean, how much of an influence does that have, kind of being that moving away from that kind of methodology?
It has around 40% influence. And then the remaining, 27% reduction we get is by creating these larger scale modules.
Got it. So Gabriel, same kind of question for you. Do you think it's predominantly an economic viability issue, or it's a hybrid technical, or how do you guys think you're attacking the same thing?
Yeah, I think I would concur with a lot of Laureen's points. I think the fact that I want to highlight a little bit more is we cannot scale the green hydrogen business with the technologies that exist today. Frankly, we don't have enough precious metals to make the gigawatts of electrolysis that we're forecasting over the next decade. So I think key to all this is how do we take the precious metals out? How can we make electrolyzers that attach with the grid? And how can we make it cheap? Which, of course, precious metals solve the scalability, or lack of precious metals solve the scalability and the cost issues. So I see those as being the components. And I guess that the way Ecolectro, which is the company I run, plays into this is we're making essentially the inner parts, the chemistry of the electrolyzer to enable that sort of removal of these expensive components and making the electrolyzers, respond efficiently to the grid, use those low-cost electrons that are also happen to be green. And that's how we play our role. But I would totally agree. First thing is get it cheap. Second thing is how do you make it scale? And I think, our approach towards green hydrogen is certainly sort of has some merit because of it.
One thing that I didn't harp on enough is that we also need to really increase the capacity, the renewable power production capacity that we currently have in the world. And that capacity doesn't need to feed into the grid because we know that will probably cause some transmission problems, right? The solution is feeding it into an electrolyzer for hydrogen generation. So one of the other challenges is rapidly scaling our renewable power production capabilities.
Makes sense. One question I get a lot from various private equity firms and folks that are really keen to start really opening up, their hydrogen landscape from an investment infrastructure perspective is, I get asked a lot, what are the primary drivers for widespread adoption, and what are some of the key advancements that need to occur from a technology perspective? You've obviously talked about electrolysis and renewable energy, cost effectiveness. There has been another, in that same light, get asked often, what does this kind of new world from a supply chain perspective look like, right? Imports have prices have gone way up. Sorry, there's the boarding call. The import costs have gone way up. Transportation, logistics costs from mainland China have gone way up. How much do you guys see kind of the new world order of things that might be here for a while influencing, and how do you see those markets opening up in today's environment?
Make sure you don't miss your flight, Ben. I'm not sure. I would say there are three drivers for any innovation. Government policy needs to be supportive, doesn't need to, carry the weight of the whole effort, but needs to be supportive. Public support, so social support. We need people to understand hydrogen is not as dangerous as they think. And then there's the economic portion, so the cost. And we see all those three things finally coming into alignment for decarbonizing industrial sectors, regardless of whether we decarbonize by hydrogen, electricity, whatever it is. And manufacturing is so key to all of it. I'm sure Gabby agrees in that we have to diversify our supply chain. We cannot now rely on the low costs that China can provide us. I mean, just shipping and the tax tariff from China is kind of negating whatever cost reduction we get on the part. And so, I mean, that's central to Alchemr's business model for manufacturing. How do we diversify that supply chain? Can we pay a bit of a premium to manufacture domestically, but then save on the transportation cost of the goods? Gabby, what do you think?
I totally agree. The only thing I would add is that it is key to understand that electrification will solve a lot of these greenhouse gas emissions, but it's not the solution to everything. And there are a lot of industries that are looking for green alternatives that are cost competitive that hydrogen can service. And I think that the best way of thinking about it is, there's a lot of great innovation around CO2 reduction. There is no CO2 reduction without green hydrogen to make fuels or chemicals. I think there is a lot of thinking about how are we decarbonize flight and transcontinental flights. And I think there are very challenging paths that, it's still challenging with hydrogen, but is there the best shot of getting there at a reasonable time? And I think if we can really show that the industry can scale, it's going to be key to having green fuels or green molecules or electrons to molecules technologies, and a lot of those pathways have green hydrogen kind of at the intersection. So I think that's the only part that I would add, but I would totally agree on the 3 points to drive innovation forward.
Yeah, pulling on that thread a little bit in terms of the aspect of time that you just mentioned, right? The latest ICPP report came out, and it's their language is progressively getting stronger around we don't have a lot of time. What does the next 2, 5, and say 10 years look like in your guys' view for the expansion of hydrogen with that time constraint, knowing we don't have a lot of time potentially for significant government policy to move the needle? I mean, things need to move quickly in our world now. So how do you guys kind of see that looking, and do you think there's promise on the near term and midterm horizons?
One thing I'll say, and then I want Gabby to go ahead and answer, is that because time is so critical, we cannot keep expecting every industry to switch to using electrons when those industries are used to using molecules, right? Natural gas. And so I think that's one of the biggest points as to why should you go from electricity to hydrogen versus just electricity. We don't have the time to make all these industries change their processes completely to adapt to electrons. And some you just can't even adapt to electrons. Gabby, do you want to go ahead and take it away on the timeline stuff?
Yeah, absolutely. I think key to time is how do you scale? How do you scale quickly? How do you scale economically? And I think there are solutions like what Laureen is working on, what we're working on, that allow you to get there super quick. I think one of the important aspects that Laureen mentioned is how do you make sure that industries continue to use assets in their balance sheet as they adopt new technology. And I'm thinking specifically of utilities and power production. How can we blend hydrogen with other, natural gas, for example, to decarbonize electricity generation? How can we potentially even replace natural gas with green hydrogen for electricity generation so that you can still use those newly installed power plants that are not going to be written off the balance sheet very easily? And that's just using utilities as an example. But I think thinking about how this product, which is green hydrogen, fits into already installed machinery, plants, production facilities is going to be key to drive adoption. And I think, one of the things is, hydrogen is a giant market today. We do a lot of things with it. So even if we can just sort of service that market economically, we would have a very successful business or economic opportunity.
Yeah, it doesn't take long for a mass adoption to occur in today's kind of economic and social climate. You look at electric vehicles, for example. They fought and resisted. And as soon as there was a wave of interest and the Teslas of the world started gaining traction, everyone, it seemed, every major car manufacturer was pivoting almost overnight, it felt like, right? So you feel like hopefully this momentum is building where all it takes is one of the BPs or Exxons or Chevrons or somebody to say, you know what, we're going all in, and it will just unlock, a mass adoption. It's just going to take that kind of the Teslas of hydrogen, those worlds to exist and to pioneer the bold next steps into this industry. And you feel like it's not far. It's right on the fringe. It's just a matter of time. Roland asked a question, piggybacks off your statement there, Gabriel, which is, looking into the future, does the green hydrogen actually ever really compete with natural gas unless you have some sort of pricing on, GHG or emissions? Do you guys have a feel for that?
Absolutely. I think the answer is unequivocally, it does compete with natural gas, especially with renewable electricity prices where they're coming down today. I think we definitely see a path to achieving, the earth shot from the DOE of getting to around $1 per kilogram within the next decade. I even think we can get there faster if technologies like what we're doing and what Laureen is doing get to market quickly. Because it just, their economics are there. Scale will get a lot of the cost of the system down, and getting the precious metals removes the last little bit of barrier and allows you to take that step change to be truly competitive with natural gas or fossil fuel derived systems. So I I'd be shocked if we don't get there this decade.
Yeah, that makes sense. There's, it's interesting you speak specifically around a bottleneck that could exist in the supply of low cost renewable energy, right? With the advancement with the internet exploding worldwide and it being adopted quite significantly with things like cryptocurrency and data centers being, it seems like, developed and built everywhere left and right. Do you guys see that there could be almost like a competitive race to attract that energy because there's so much demand for things in high industry growths that are needing it, and obviously the supply can be constrained just on how many developments and the expansion of that and base load power versus intermittent power and all these things? Like, how do you foresee kind of all of that coming together and the competitive forces with other industries like those?
You can definitely look at the parallels in other sectors such as the solar industry, the wind now as well. And EVs is kind of getting to that bottleneck where people are saying, well, there's a limited supply of lithium, right? And there's all these different applications they want to use for batteries. But in our case, for the renewable power, it just makes sense to continue building these renewable power assets and have some that are dedicated to, let's say, electrolysis and others for the grid. And I don't see a point in which we'll get so much capacity or so little capacity that we're fighting over it, right? We can definitely meet the world's demand of electricity plus the demand in green hydrogen, which is only around 30% of today's electricity production, which sounds like a lot, 30%, but it's definitely a surmountable challenge to get to that capacity before 2050.
Yeah, I think I agree. We're going to have electricity, and we're going to need to use that electricity for the continued manufacturing of a lot of industries. So I don't think there's going to be a limited amount of electricity. In fact, with offshore wind technology where it's at today, with new wind panels, PV installations, if you look at the growth curve of some of those gigawatts of power, I think there's certainly going to be enough power to move the needle on this.
And one thing to keep in mind is just human behavior. So at this point, we really understand how to build our wind power plants onshore, our solar. And we know that that's one of the keys to decarbonization and to stop having these flash floods and this drought and fires. And so people are going to want to keep doing this thing that they know how to do already, and they feel it's helping, right? And that's where renewable power comes in.
So expanding from there, we, in preparation for this, I was reading a lot of information, found an interesting global survey conducted by a leading research firm where the following question was posed: how will hydrogen be transported in a new global energy trade? And the following three responses were the most consistent. 1, the hydrogen economy is really actually an ammonia economy. 2, liquid organic hydrogen carriers will be the dominant hydrogen transport method. And 3, hydrogen is bound to be limited to local production and consumption only. Very interesting perspectives that kind of have three almost completely diverse tentacles, if you will. So from your perspective, do any of these responses resonate with you the most directly, or do you feel that they're missing the mark? And what do you feel is the most likely outcome? Start with you, Laureen, or it doesn't matter, or Gabriel.
Maybe we'll disagree on this one, Gabby. Let's see. So I think all three are going to play a part. The ammonia is going to play a part maybe around for 30% of hydrogen transportation for across the ocean, right? Country to country. I think ammonia is key. And then for these liquid hydrogen carriers, whatever you choose all comes down to the gravimetric energy density, the volumetric energy density, and then the cost of that solution. So these liquid hydrogen carriers I see as being more suitable for a smaller distance for transportation versus having perhaps trucking in your hydrogen as they're doing today. And then of course we're going to have distributed hydrogen where it's generated on site. Why would you put a transportation step if you don't need to? And that's where scalable water electrolysis really comes into play. Can you have a system with a small footprint, sits on site? And then can you also have a system that's huge for a huge chemical plant? Those are my thoughts. So all three combination, they're totally different when you look at their technical values.
Yeah, I think my view on this is that there's going to be more than one solution to this issue, and how it's used and where you use it and how you use it. And because the hydrogen you need for powering a fuel cell car is totally different than the hydrogen you use in an ammonia factory or in a Haber-Bosch plant. So I think the same way that there's different hydrogen products, even though it all might be green, it's just going to drive a lot of what the use case ultimately is. But absolutely agree with Laureen. Ammonia makes sense if you want to truck it on a tanker boat across the ocean. It's easier to do that than to compress hydrogen and send it around. So I think it's going to be application dependent, and that's a cop-out answer, but I think it's really going to be application dependent.
Yeah, makes sense. Lacey actually asked a question for those in the audience that are interested in hearing something specific from Leo and Gabriel. Feel free to ask some questions there in the chat area. She actually was hoping you guys could elaborate a little bit more on actually how your technology works and kind of how that process fits. And maybe we'll start with Gabby on this one. Can you jump in, and then we'll move over to Laureen and kind of maybe get under the hood a little bit with whatever level you guys feel comfortable. Yeah,
I think this is a great question for us both to answer, because I think in a way, Laureen builds some technology like ours in some ways, right? So we make chemical solutions. So we make all the chemistry that goes inside the electrolyzer. And the best way of explaining it is we make the electrochemical cell, which is like a battery, that takes water, renewable power, and hydrogen and oxygen comes out. And that's how it works sort of at the chemistry level. And I think what Laureen does is, how do you engineer the system that makes this work? But I'll leave you to talk a little bit more about it.
Oh, that's all you weren't going to go? Okay. I'll try out. So what he said, with the addition of some hydroxide ions in an alkaline environment, we'll just throw those words in there. But yes, water's going in, and out comes oxygen and hydrogen. And so what we do is, like Gabby said, build off the membrane. So we are the ones that are manufacturing electrodes, figuring out how do you make both the membrane electrode assembly durable to last thousands and thousands of hours. Gabby also works on this. But our differentiator is that we are the ones that are actually figuring out how do you put this thing into a cell and run it. Because the way these anion exchange water electrolyzers operate, they're not the same as the existing solutions in terms of how they behave when you actually, put some charge into it and water is flowing. So we engineer the cell architecture, which lets us get to this 500 kilowatt to 1 megawatt stacks. And Alchemr is actually the first to achieve a 2 kilowatt single cell, which is our building block to get to these stacks. So we're really excited about that. Lacey, did that make sense?
We'll give her a minute to respond there. Yep, looks like you got a thumbs up. We'll let you guys slide on grilling you any further on that. But they both have great websites for those that want to explore a little bit more and go, and there's some good content there, and I'm sure they'd be happy to connect with anybody following this as well if you have more detailed questions.
One thing to mention, Ben, though, that I think is really important about the technologies that we both have, although cost ultimately is what it comes down to. There are two things you need to keep in mind for green hydrogen production. You have to couple to intermittent renewable power sources. And to do so effectively, it needs to be a solid state system. So our technologies are solid state. And then point B, you want to avoid those precious metals, and therefore you can't be in an acidic environment. So you need to be in an alkaline environment, thus the exchanging of hydroxides, rather hydrogen ions. So those are the two big pros of anion exchange water electrolyzers that Gabby and I work on. So in terms of looking at going back to the kind of
the government role here, right, a little bit more. Roland has asked a question too, and I think it's pulling on a thread from earlier part of the conversation. You look at things like production tax credits that really helped empower the expansion of aspects of the solar industry. You look at the renewable fuel standard and low carbon fuel standard, the RFS, the LCFS credit programs that have really helped renewable natural gas and various different pathways exist, have really opened up those markets, and anaerobic digestion, RNG, and biofuels are starting to expand it quite quickly. Do you guys have a good view or line of sight into any of the current, the current or imminent government subsidy programs that might be opening up to support the expansion of hydrogen in those same fashions? And can you speak to what you know about those a little bit?
Yeah, there's a lot of great bills being passed around right now in Congress. The infrastructure bill itself contains language to support green hydrogen production, such as, $3 per kilogram off if it's green. Gabby, what else have you seen?
I think the biggest I guess policy that we could establish, which places like Norway have already, is putting a price on emissions, right? If you price emissions, I think everything else it becomes a lot more competitive immediately. So I think but that's showing, I guess, a preference over one type of policy than others. But I agree. I mean, there's a lot of good policy being put out to achieve scale. There's a lot of good policy put out to sort of drive some of these adoptions. I think when you think also about the net zero transitions that all of these oil and gas majors are doing, there's no view towards net zero that hydrogen is not part of. So I think there's going to be a combination of both, public policy and strategic direction with private enterprise that's going to really drive things forward quite a bit.
Now, although a carbon tax that he mentioned would be nice, we are both working on solutions that wouldn't need that to get off the ground.
Yeah, that's a good point. Thank you for adding that, Laureen. I think it's important to say that because I think key to any clean tech or climate tech industry is how do you make it so that you don't have a green premium for a cleaner alternative, and that's certainly the direction that we're headed.
Yeah, it makes sense. I mean, a part of the conversation often gets missed is even just the geographic aspect, right? We have a tendency to gravitate toward our knowledge of how the U.S. is functioning and where we see that market going, but the global perspective is also just as important. And you look at Canada, where I'm sitting currently. They do have a recently upheld Supreme Court ruling around carbon tax escalating up to $50 a ton by 2030, right? So have you guys, do you think that there's a chance that, maybe places like Canada or other, places in Western Europe that might actually see the hydrogen economy boom before potentially even the United States? Or how do you guys think what do you guys think the landscape might look like in terms of the geographic footprint of this economy?
We're already seeing people flocking to Europe because they have such great policy for hydrogen. You're also seeing it now forming locally in Vienna. You have, where else? You have Spain looking more closely at these things. So yeah, I definitely think everyone's racing. Europe is ahead, we must admit. So yeah. It's definitely going to be a global operation. And that's also one challenge that we need to think about. It's a complex value chain. And I can't recall which report, but they basically map out which countries are going to be exporters and which are going to be importers of green hydrogen. And it's just amazing to see how all the countries become connected. So one thing that definitely needs to be worked on in tandem with lowering the cost of production is this policy, how countries work together for the transportation of hydrogen, and then all along the value chain of renewable power producers, transporters, hydrogen producers down to the customer.
Yeah.
Any thoughts on that, Gabby?
Agreed 100%.
Yeah. So, thinking a little bit more about, these emerging technologies that are, empowering this likely growth. I'm a little curious to hear a little bit about your guys' story, because at the end of the day, everybody needs funding to get these things off the ground and to expand, right? Have you guys seen the venture capital world and some of these early stage investors really gravitating to businesses like yourself who are finding the next great mousetrap to open up what they believe to be a big economy? Or are you still seeing hesitancy? I'm curious a little bit on kind of how you're seeing the investment community seek out and the types of conversations you're having when you're looking at funding or you're looking at expansion opportunities.
Yeah, I think maybe I can take it first, Laureen, or would you like to go first?
No, please go ahead.
I think that there's a number of very promising aspects in the sort of private capital perspective. I think there is a lot of money willing to be deployed into technologies like these. I think in some ways the challenge is, how do you do smaller deals to get some emerging technologies out into the market quickly? So, I think we've been very fortunate to have received a lot of R&D dollars from the federal and state government here in New York State, where we're based. And that has certainly funded a lot of the early innovation in our company. And we have a great crew of investors who've supported us throughout. But I think the challenge is there's a lot of people interested in hydrogen suddenly, and how do you finance some of the earlier stage technologies that are emerging that have promise and merit?
Laureen, how's your journey been, and how are your conversations going?
We too have been really blessed with being able to tap into non-dilutive funding, so around 3.7 million at this point, which we're proud of. But at the same time, we are trying to do something huge, and we need to do it fast. And so it's not enough to rely on these non-dilutive funding grants. So we are getting into equity financing, and what I've seen is a mix. Most of the investors are hesitant. They think it's early. They're preferring to invest into projects, like deployed projects, even though it's really hard to imagine the cost of hydrogen production from those projects ever being really economically attractive. And then there are a few that just instantly get it. They're like, yes, this is amazing, and we want to invest. But the majority is hesitant. So if you get it, you get it. If you don't, I guess you don't.
Yeah, no, it's challenging, right? Talk. It's finding the right people is as important as just gaining access to the market, liquid markets, right? And I often get asked. I probably 10 times a week I hear from clients or prospective clients in the development community of developing projects with technologies like yours. I keep hearing there's billions of dollars and trillions of dollars on the sideline. Why can't I get it, right? And it's hard to get financing, especially at the project level, from the intensity of underwriting requirements. And it's frustrating because people keep reading and hearing how much money's out there, and I like to ask the question of lots of different folks to understand their journey, because it is a challenge to unlock that capital, even though it is there, right? Or so it's interesting to hear your perspective on that. One of the questions I actually got this morning, ironically enough, when I was telling somebody about we're having this panel with you two, was a relatively basic question, but I think one that could be interesting for the audience to hear the answer to, and I think I know what your two view is going to be, but I think for the purpose of this conversation, we'll have it. There's a lot of colors flying around in hydrogen, right? Gray, blue, green. Can you guys, one of you or both of you, kind of maybe give a little bit of an overview of what the difference is between gray, blue, and green hydrogen, and kind of how you personally see the gray and blue aspects? Obviously, there's a lot of difference of mission profiles and things, but do you think they play a role and need to play a role, or do you think that that's too detrimental to the future of hydrogen? A little bit curious on your views there.
Go ahead, Gabby, if you'd like.
I think it's an interesting question. I think it also embarks in a lot of sort of complex ecosystems, because if we don't have gray hydrogen today, we can't feed the world because we can't make fertilizer, right? And that's just, and I think we would all agree we don't want to not feed the world. But I think in terms of blue versus gray versus green, I think the important thing is to know, ultimately, I personally think, and I'm biased because I'm working in the green hydrogen space, that we need to make all hydrogen green, because one, not being reliant on a fossil fuel is going to be important. And two, the emissions are just so much lower, even if you capture carbon eventually. But of course, blue hydrogen, which is when you capture carbon from steam methane reformation of natural gas, is better than gray. And green is obviously best in emissions point of view.
I have a bit of a different opinion. Yes, we definitely need to feed the world. So the existing gray hydrogen production assets will have to keep running until we can, switch over to green. But I am very much so against blue hydrogen. So in terms of building new assets and then sticking on carbon capture, we do not have time for incremental improvements. We need to, if we're going to spend the money on a new asset, go all the way green. What's the point of first going to blue and then green? That's my opinion.
Yeah, I agree with that. I just think, I guess what I'm trying to say is that blue is better than gray, but we should move
Definitely
to as quickly as possible. So just
well, a lot of these questions come down to, the answers come down to what will happen versus what should happen, right? Yeah. And that's the unfortunate, whether we like it or not, the global economy and the way globalization is. It's very difficult conversation to have, because I think generally we all know what should happen, but the question is what will likely happen based on just the way our economic and political influences and forces occur in today's environment. It's interesting.
I will say that I've been surprised by public opinion as to the blue versus green argument. I found that a lot of people, I would say it's half-half, 50-50 of people think we should just go straight to green versus blue. And I'm going to try to move away from the color. So basically go from zero emission to not really zero emission, because you have these methane leaks, you have fracking, people not having access to water that doesn't light on fire, things of that sort. So I do have hope that what we will do is also what we should do. That hope is like teetering on living that.
Yeah. Well, and that comes back to the earlier conversation around things like, public opinion, government support, et cetera, right? If massive amounts of funding comes in for green hydrogen, that's where people will go, right? And so I think you're right. I mean, it all comes back to those three pillars that ultimately drive what this outcome looks like, largely because the economic viability of these projects is arguably the most important, but is one of the most important relative to the investors that are driving these markets forward. So it's definitely a challenge. We see this in a lot of markets, right? It's not just hydrogen. This is always a philosophical debate to some extent, but it's an interesting one to have nonetheless. Let's see here. We had Jim Bono's asked a question and is curious on both your views on what does the next 20 years look like when your technology succeeds, not if. So you guys are deploying. Both your businesses have grown substantially. What does your view of, say, call it 2040, 2050 look like in terms of the deployment of your electrolyzers?
I think the answer is, to the average person, their use cases, if we are successful, will remain relatively the same. I think what will happen is that the way in which we use, things like energy and come from cleaner sources. I also think that, you will still fly on planes and they will be powered with renewable fuels. So I think to the average person, the world would, in a very optimistic point of view, the world would look much the same, except we wouldn't be emitting so much CO2 into the air. And I think that's certainly where I'd like things to see, because I think that will certainly be very successful if we can get there as a society.
Agreed. By 2040, Alchemr will have reduced emissions on the order of gigatons, of course, with the help of components such as Gabriel's. And we will have a lot of the same processes that we already have in terms of I just press a button and now my heater is on and I don't realize that it's green hydrogen heating up the house. But I also believe that microgrids and DER, deregulated energy resources, will become more common so that we don't overload our grid with all the renewable power that will be in the world by 2040. And it'll be archaic that people ever used fossil fuels.
Yeah. So looking forward for both of your businesses respectively, do you see yourself predominantly being a technology developer or supplier, or do you guys see yourselves actually expanding into the development of projects where you would deploy your own technologies and expanding your teams into more of a developer, owner, operator of green hydrogen assets, or do you see yourself predominantly being a technology or a equipment manufacturer and provider and scaling that way more on the manufacturing side?
I'm trying to see, is there anyone from Shell or Exxon on the chat? I don't think so, but if they are, don't get mad at me. We see ourselves as becoming the oil and gas companies of the future. So whether that means Shell is completely green and we're also completely green, serving the same kind of customers, that's where we see ourselves.
Yeah, I think I agree in that we would be the technology engine for the oil and gas producers of the future that don't produce oil and gas, actually. They're just
acquisitions and mergers in the future.
We'll acquire them.
There we go. I like the ambition.
And then we'll need to work with companies like yours, Ben, to actually get these projects up and running. We can't do this alone. It will take multiple players along the value chain and integrators as well.
Yeah, it's an interesting discussion around the development aspect of projects that deploy these technologies and all these verticals, right? You see it a lot in, like I said, in RNG with gas upgrading technology and things like that. But you're only as these complexities of these projects and these economies are only as good as the weakest link to some extent, right? And what I've seen personally is over the past maybe 10 to 20 years, you've seen the developers trying to shift into low carbon infrastructure, but it's just a very different world than what we've come from, right? You had a world where you were predominantly things like, fossil fuel power generation, like combined cycle power plants, and you had non-organic and homogeneous fuel supplies, things that were pretty easy to manage. These like midstream pipelines, compressor stations, these things have been done for 50, 100 years. They're fairly cookie cutter. There's stability. Investors are comfortable because they know exactly what the risk appetite is. But now you're in a world, right, where with all these new kind of low carbon emerging sustainable infrastructure sectors where you have organics at play, which is a completely different world when you're talking about, feedstock supply. You have markets that are not as well understood that are emerging. You have subsidy dependency, which can get a lot of investors uncomfortable depending on, who's in office or what the political regime could or could not look like over, the next several election cycles, et cetera. You have engineering, procurement, and construction companies that can't offer necessarily the performance guarantees that are required for new technologies because they've never built these things before. So it's a really interesting landscape to see. And it kind of goes back to the conversation earlier around there is a lot of money, right? There's Nexus PMG, for example, we have over 75 infrastructure fund clients, and they're calling pretty consistently saying we want to put money to the work in these verticals. This is where we're trying to deploy, but we're really struggling to underwrite. These things are complex to put together. And so I do think that that's going to be a big part of your business, whether you decide to partner or you decide to, maybe it's a little bit of both, you decide to grow in-house. But controlling your own destiny to some extent, whether it's one of those two, is really key, because without really strong development teams and partners to pull these complex projects together to an underwritable state to get $100, $200, $500 million put to work is really critical. And we see a lot of really amazing technologies in other verticals, for example, that are really advanced. They just can't get the development community to actually get the projects to a point where they can deploy. And so they'll be a key part of that. And so I imagine that won't be far if it's not already on your radar, is how are we going to scale? Because it's not just I can make enough of these, it's how am I going to get them out there in the world, right? So it'll be interesting to see how you guys attack those challenges as you move through the life cycle of your businesses. So Roland here has asked, in the short term, and let's just say next few years perhaps, what can we expect as the quote unquote better application of green hydrogen? So say it's 24 months from now, what do you think is kind of that better application? Do you see you guys are seeing the early indication of a one or two specific use cases that are really starting to gain a lot of momentum quickly?
I'll go ahead. One thing to build off of what you said, Ben, is we're not just building a technology, we're building a business and an ecosystem around the technology, because we do understand it takes all of those elements to make it successful. So I think you're spot on that these projects are complex and difficult, and it won't be as easy as, let me toss my electrolyzer onto the ground over there and you can use the hydrogen. As for the application projects, this is the gazillion dollar question, right? What is the perfect beachhead market for green hydrogen? And we have our own thoughts on it that we aren't really disclosing as of yet, but I can say that some of the leading applications are the heavy duty trucking, where they can't get from California to North Carolina off of EVs. California has this interesting strategy of really promoting passenger vehicles for hydrogen, and that's primarily to get the infrastructure up, right, for the hydrogen refueling stations, versus them believing it's the better option. And other applications near term, short term, are backup power generation as well. I think we don't talk enough about.
Yeah, I think it's a good question. I think, trucking fuel makes a lot of sense. That's the highest cost hydrogen you can get. Even gray hydrogen for these applications is much more expensive because of all the purification you have to do and compression and all of that thing. So I think what we're talking about when we say this dollar per kilo is really industrial hydrogen cost, which by definition, green hydrogen is much cleaner than any SMR or blue hydrogen or gray hydrogen. So it definitely has an advantage there. I also think that there's a lot of things where we can put green hydrogen today that require no change in anything, right? Just put it into the natural gas pipeline.
Float glass manufacturing already uses hydrogen.
Yeah. So I think that's, it's really less difficult to find than people really think.
Yeah, it's more so trying to say what is, the best application right now.
Yeah.
Well, we have 1 minute left before our wonderful organizers want to reorient and get prepared for the future sessions here. Gabby, Laureen, what's the best way for people to connect with you? Where are you guys active? And how would you like to have those that are interested in having further conversations reach out and get in touch with you?
I think we'll both add our email addresses in the chat. And I'm also accessible via LinkedIn. I try to post kind of frequently. I need to do better, but that's where I'm at. I haven't got on the Instagram train yet. Maybe one day, maybe not.
Yeah,
it's good for your mental health.
Probably.
Yeah. I just put my email in the chat. I'm also pretty active on LinkedIn. I don't post, but I do check LinkedIn frequently. So that's probably the best way of getting a hold of me. We're also based in Ithaca, New York. So if any of you make it towards this area of the world, you're welcome to visit, and we'd be delighted to host you.
Good point. We're located in South Florida, so just drive down after you visit Gabby's facility and we'll see you.
I think those that are interested in the winter will probably go see Gabby, and some will go see Laureen. All right. Hey, welcome back, Zoe. I'll cease to annoy the audience and let you take over.
Awesome. Thank you so much, Ben, for moderating. Laureen and Gabby, amazing job. It was so awesome hearing about the technologies you're building and all the hard work that you've achieved. So lucky to have people like you out there changing the world. With that, those are our final sessions for today. So we're all going to hop back over to the main stage for closing remarks from our managing director, Jackie and Mobley.
Thank you, Zoe. Thank you, Ben and Gabby.
Absolutely. Thanks, guys.
Thank you.
Have a good one.